Hello and welcome to the Virtual Jug, and welcome to our 57th Virtual Jug session as well, the last Virtual Jug session, other than a book club session tomorrow, of 2015, as Oleg pointed out actually backstage. Joining us today we have Sven Efftinge and we have Miro Spönemann. How are you doing, guys?
Hi, how are you? Fine, hi.
Very well, thanks. And where are you guys calling in from today?
We are in Kiel, in northern Germany.
Awesome, awesome. And how's the weather there?
As always, great.
Well, probably better than here in the UK. And we have Oleg as well. How are you getting on, Oleg?
Pretty good, pretty good. The weather in Estonia is always terrible, so I'm really happy for you.
And I hear we're doing really well on the Rebel Labs Java 8 cheat sheet. That went very, very well, I think.
Yeah, that's all times popular. I guess best practices attract people. So
that's true.
Be sure to check that out.
Okay, so I'm just going to quickly share my screen so we can see what we're doing today. On the Virtual Jug, then, we are looking at a session called Programming Language Development Made Easy. And our speakers, as I mentioned, Sven Efftinge and Miro Spönemann. Sven is on Twitter at Sven Efftinge. Miro is not currently on Twitter, so we should definitely email Miro and get him on Twitter. The Virtual Jug is sponsored by Zero Turnaround, and media partner. You'll see all our VJug write-ups on Rebel Labs. The Zero Turnaround, proud sponsors of the Virtual Jug. You can look at a couple of products that they do. JRebel, which allows you to instantly see your code changes in your runtime, and Xrebel, a lightweight Java profiler for Java developers. Also, JRebel for Android reached version 1.0 just yesterday. So if you're interested in Android development, you can update your code and resources instantly on your devices and emulators using that. If you'd like to hear more about that, go to zeroturnaround.com and you can get some free trials of all those products. So the Virtual Jug, if you wanted to engage us and discuss and ask questions, you can do so on IRC. You can go to Freenode and join channel #Virtual Jug. Do ask questions there and we'll ask them directly to the guys on the session today. Please do share the group and session. We are almost at 5,000 members. We're about 100 members short now. So please do share this group. Tell everyone how awesome we are and all the awesome content we've got, and we'll aim to get to 5,000 members by the end of this year. If you do have any feedback about this session or in general, do contact us on Twitter at Virtual Jug or myself directly at SJMaple. So that's pretty much it for the intro. So I'm going to pass straight over to Sven and Miro. There we go.
Okay.
And there we go.
All right.
Please, let's talk about how we develop programming language.
Okay, let me share the screen. Oh no, that's the wrong one. All right. Oh, yeah, we're going to talk about language engineering, language development. And so, yeah, we use Xtext for that. So that's the idea. And the session is going to be some slides in the beginning, so we put in some context. And then later we will have demos, different demos. And as Simon already mentioned, you can ask questions, especially during the demos. And if Simon sees them, he will ask them to us directly, so we can just answer them. All right. So in this slide here, it's called DSL Engineering. Well, with Xtext, like, you can develop programming languages, and if you want to build a programming language, you probably know why. The question is, like, why would we need a domain-specific language? So what's that good for? Which is more interesting to many more people than building like full-blown programming languages. So for us, a domain-specific language is just a really a computer programming language, but that is kind of specialized for a certain thing to do. So it's really kind of a suited abstraction for a certain task, like SQL or regular expressions, and being very popular, DSLs, but also like build file languages and so on. So why is that a good idea? So the first thing is, like everyone says that these days, we have software everywhere. Like software is going into every kind of industry, everything is pimped up with software these days. And we as software engineers, we need to write all this software. And we need to do so, we need to talk to the people in that domain and understand what the requirements are. And as you all know, there's always this gap. So we need to understand what they want, and actually the people need in the first place to understand what they want. And we need to, like, through good interviews, explain them what's kind of, how we could map that to software and so on. But there's always this gap, and in bigger projects we have these requirements, documents, these endless things, and so on. And then we have the big software systems, and big software systems need to be maintained. And the best thing to do to have a maintainable software system is to build proper abstractions. So with general programming, we do that all the time. When we define a method, or we compose many methods to a new method, then that's kind of like with Lego bricks, building abstractions based on other abstractions and so on. And it works very well for functions and so on, and in some case it also works a bit for structures, but then there's many problems where, like, general programming languages don't have really good recipes to get rid of redundancy and build proper abstractions. So that's especially the case in Java, and that's why we have so much boilerplate everywhere in Java programming. So these kind of duplication and lack of good abstractions also hurts in terms of maintainability, which is a very important aspect in software engineering. Like the half-life of software is an important property, so it needs to be maintainable. And that's done by good separation, but also by having good abstractions. And sometimes APIs are just not enough. Think of Lego, like you have bricks and you can build almost everything, but then there is stuff like wheels or plane wings and so on. That's also the reason why I had this 3D printer on the first slide. Xtext is, so to say, the 3D printer for software engineering, where you can build your own Lego bricks, so to say. And then that's another very important thing, is when you build a domain-specific language that kind of reflects a certain problem very, very nicely, such that it is more readable and maybe even readable to the business people or domain people, or even maybe writable. Well, that's like for engineers, that's a thing that could work. Like if you have insurance companies with mathematicians that build like insurance products that are mathematically very complex, then you could have a domain-specific language to write and author them, these products. So now imagine you say, well, okay, I have some applications where a language, being a domain-specific language or whatever, a programming language, would be beneficial. Then the next thing is like to look at the cost, or to look at like how would we do it. The first things that come to mind when you build a domain-specific language is that, well, we need to kind of have a parser, right? If a language is textual, we need to parse the text somehow. Actually, you also usually have a lexer, which is the first phase, but it's just a technical thing. But what do you do then? Then you need to kind of do something with it. And in order to do so, a good pattern is to let the parser just create an in-memory model, a so-called abstract syntax tree. So you need to have classes for that. And then you just take the model and you do something with it. For instance, you generate code in a target language like Java or C or whatever you have it. Or you run an interpreter. So in memory, you parse the syntax, you have an AST, and then you have an interpreter that does side effects in the systems. But that's not all you need in kind of a language compiler. There's stuff like validation. You want to have checks so your users get feedback early. You want to have a linker in order to use static typing, so you define things at one place, you want to refer to them at another place. You might want to have a type checker or a type inference engine because you don't want to be so loud as Java is. Make it very readable and expressible. And that's just the runtime stuff. And then, like, we are in 2015, and you know, if you build a language, then you need to also provide decent tools. So then we are looking into IDE features, or like whatever kind of text editor features or so. And there's a lot of things you might want to have, especially if you kind of build a language for people that are like not super technical, then they need more assistance, or you build a language for Java people that are used to stuff like this, and they want to have that, they don't want to kind of compromise on this. And then you maybe have even a mixed team, like Eclipse users or IntelliJ users, or you build domain-specific languages for some business people like the insurance mathematicians I mentioned. Then you might want to have this stuff in the browser. And then it turns out, like, if you look at that, well, that will be a lot of effort to build the thing, and then even more so to maintain it over time, because abstractions, they live with the changes. Like an API in your own project, you need to be able to evolve it. And so you do so also with DSLs to match your current requirements. And so that's the space which Xtext targets. And it lets you define languages, textual languages, with a primary grammar language. And from that, you get all the things I mentioned previously, like all the runtime stuff, the compiler architecture, and you also get all the IDEs and so on. The thing is, at first, you just start with the grammar, and you get the whole infrastructure that is wired up using dependency injection. So Xtext uses Google Juice for that. And by doing so, it can bind all kinds of interesting default implementations, like stuff we've seen in many languages, how scoping works, how namespaces are resolved, and so on. And that all works by default. And then you can go there, like in a Spring application, and say, well, for me, this aspect is a bit different, so I want to change it. And you only need to kind of change this. So that's how Xtext scales from simple languages to full-blown programming languages, including full-blown IDEs and so on. It supports multiple platforms. Currently, it's Eclipse, IntelliJ, and web editors, 3 different web editor frameworks. Behind that, there is a runtime framework, like a compiler architecture, and also some UI services, like Content Assist, that are platform independent. And it also integrates with Maven and Gradle, so it's all running on the JVM. And it comes with, like, for your language projects, with Maven and Gradle integration, but also for when you deliver your languages to some downstream clients that would be Java projects. It's very easy to integrate the code generation and the language stuff into your continuous integration builds. Short overview of the history of Xtext. We started the project in May 2008 at Eclipse.org, so it's open source. Had a first version in 2009, and with that got already a nice award, being the most innovative project in 2010 at the Eclipse.org Foundation. Then we had a version every year together with the big Eclipse release. But since June 2012, we started to release more often. Then in 2014, we had the first conference, which is all about Xtext, called XtextCon. It's a community gathering with 130 people coming to Kiel, actually, to where we are here based. We talk 3 days. We talk about all aspects of Xtext and language design there. We did that conference this year again, and just released the version 2.9, which we are going to show you today. All right, so that's for the introduction. I hand over to Miro now for our home automation example and a demo.
Yeah, thanks, Sven. So the domain we're looking at in our example here is home automation, and so this is an example of a language that we will look at. So here in this language we can define devices like a window or a heating, and these devices can have different states, like a window can be open and closed. And in order to implement the automation, we want to be able to define rules. For example, when the heating is turned on, then we want to open the window. Well, this is of course, this is of course maybe not the best thing you should do there. So probably we should change that to close the window when the heating is turned on. So what I will do next is I will create an Xtext project from scratch and just show a few examples of how you can define your language and define some of the behavior of the language. And I will use some code snippets for that. And I published the code snippets on GitHub, so if you want, you can look at that up and try it yourself. Okay, I will do the development using Eclipse, and here it starts using the project wizard. And we will select Xtext project and call the project org Xtext example home. Then we also need a language name and a file extension for the language files that will be created. So now we can select which integrations we would like to have. So in this case, I will say I don't need the Eclipse integration plugin, but I want integration into IntelliJ IDEA and into a web application. And in this case, in order to make it work, I would have to select a build system, and here I will take Gradle. So here we are using Gradle to do all the project setup. So if you create this kind of project for the first time, it will take a bit longer because all the dependencies have to be resolved. This time the dependencies are already in our Gradle cache, so everything is already set up. And here, this file is the grammar definition file. And in order to get started, I will get the snippet from my online example. So in this comment above, we see the something similar to the example we saw on the slides. So 2 devices, device declarations, window and heating, and here 2 rules. And further below, we have the grammar definition, or one possible grammar that implements this language. So let's just see step by step how this works. The first rule of our grammar is the entry rule, and here we say that our model consists of declarations. We can have many of these. And a declaration is either a device or a rule. A device starts with a keyword device, followed by an identifier, which is assigned to a name property. And then we have an optional part, which is seen by this question mark here. Here we can define states of the device, and if we have more than one state, then we separate these by comma. And a state is just an identifier. So in the example above, for open and closed are both states, and these two states are contained by the device called window. Then finally a rule starts with a keyword rule, followed by a description, which is just a string, and then a trigger, so that's the condition when the rule is active, and an action. So the trigger is the when part and the action is the then part. And both of these are just references to states that we have already defined in one of our devices. So the square brackets here show us that this is a cross-reference, and the state is exactly the state that has been defined here for the devices. And we say we want to use the qualified name token to reference these. Okay, as Sven already mentioned, our approach is single sourcing. So this is the main source of our language that defines how the structure and the abstract syntax tree of a language looks like. So what we have to do next is to generate the infrastructure for our language. And we will use Gradle for that in this case. So do we have the generation task here?
Next project.
This one. Okay, there's a Gradle task to do the infrastructure generation. Done, okay. So now we see that in our projects we have a lot more source code that is derived from this grammar definition. Okay, so the source code that has been generated here also already includes a parser. So next we will just test this parser to see if it really does what we expect. So, and Xtext has already generated a stub to write a test for our parser. So I will use the stub in my on my GitHub account, here the parsing test. Okay, so this kind of test, of course, could be implemented in Java. Here we chose to implement it in another programming language called Xtend, which is just built on top of Java. So actually, from this language we generate Java code. And the reason I'm using this one here is to just give you some impressions of how this language looks like. We like to use it very much. Actually, I'm using it for all my Java projects currently. And so one very nice property of this language, for example, is rich strings. So this part here is a string declaration that allows multi-lines. So I can put in a whole code snippet here and say, please parse this snippet, and then I can get a model that is derived from this text. And yeah, here, first thing that is already done, I assert that this model is not null. So now I can do some more assertions. For example, we see here we have two devices, so I could say we assert that the number of devices is 2. Declarations, filter them by type device, and that the number of these devices should be 2. Oh yeah. And the same is also for the rules. So here in this case, no. Assert that we have 2 rules in a model. So let's see if this works. I will run the class as JUnit test. And the test is green. Perfect. So what we have already seen here is that we have two Java classes, device and rule. We can also see them in the import list of our class here. And these classes have been generated by our code generator according to the structure of our language. So this is already a very nice property, so we can use these classes for static typing to work with our abstract syntax tree. Okay, so let's as next step do a code generation. We could do some Java code generation in order to put in some real behavior. That will take a bit longer, so I will instead just do just generate a simple text file. And let's start by writing a test for that. And I will take the snippet to start. Here it is. Okay, so here we have the same example that we have seen before, and we see here that we are using a standard component of Xtext in a generator that can be used to generate the code out of this, and the result of this generator will be some text content. And what I can do here, I can test whether the text content is as I expect it to be, and let's say I expect the text content to be an overview of my file that says we have two devices and the names of these devices are heating and window. So the device names sorted by name. So, and we want to do this test with a simple string comparison, so we will compare this with the generator result. Okay. If I run this, I would expect it to fail because we haven't defined our code generator yet. Okay, so in order to make the test work, we have to define this kind of behavior for our language. And Xtext has already created a stub for implementing the generator when we created the project and ran the language infrastructure generator. So I will just copy a small snippet to get started here. Okay, so here we have our model as input, and we can generate some text files out of that. So let's do that. We generate a file. We'll call it overview text, and the file content will. For that, we will again use a rich string. And now we will see another very nice property of a rich string. That is, we can put escapes into the string so that we can generate some dynamic content in our file. So first I will get the list of devices from our model. So I will take the model declarations and filter them by device. And the first thing we want to see here is the number of devices. Let's see what we expected after that. So we want to have this text, two devices with names. And then just the names. So here we can say devices. We will map this list of devices to their names. Sort this list and join it by comma. So I would now expect our test to work after this adaptation, and it's green. Nice. So yeah, this of course doesn't add any behavior, but it's just a getting started guide, so you can see how easy it is to add a generator to your language. As a next step, let's see the language in action. So let's see how it behaves inside an IDE. And I chose in the beginning not to create an Eclipse integration, but to have an IntelliJ idea generator integration. And so here we'll actually do some cross-platform development. So I have a Gradle task that I can use to run IntelliJ idea, including my language as a plugin. So the task is not on the parent project?
In the idea project.
Ah, yeah.
Run idea.
I don't see it.
Yeah.
Ah, yeah. I expected that to be sorted by name, actually. Okay. Good. So now Gradle will compile everything, put together the IDEA integration plugin, and actually start a new instance of IDEA that includes our language plugin. Good. Let's create a new project to test it. So the screen resolution is a bit lower now, but I think it's enough. Okay, so and in this new project, I will create a new file with extension home, which is exactly the file extension that I chose when I created the project. And so now I have an empty file, and if I do control space for, I already get a list of possible words that I can use to start writing here. So I can define devices or rules. I will again use a snippet that I can paste here. So here we see the syntax coloring, so all the keywords here are marked properly, the string is marked properly, and we have proper cross-references. So for example, this reference to heating state off is linked to this definition up here. And if I do control space here, I actually get a list of all the defined states in our heating device. Or in this case, I would get all the defined states. And if I change the name of the device up here, I also get a linking error. So in this case, we see the device name, the state name off is not available anymore. We can also activate the code generator in IDEA.
Just select the project.
Okay. So in order to do that, I will just add our home automation plugin for this, and here we can activate the compiler. And once I have done that, we see there's a source gen folder that contains exactly the overview file that I have defined. So let's put this file aside, and so here we can see if I define a new device, this is immediately reflected in our generated file on the right here. Okay, that's about what I wanted to show about the IDE integration. Let's go back to Eclipse. Maybe close this. And as a last step, show the IntelliJ integration.
Web, you mean?
The web integration, sorry. So, and we also have a Gradle task for that. So there's a web integration project that has a task called Jetty Run, which starts a local Jetty server. And here on the command line, we see server started on this address. I will just type that into my web browser, and let's see here a generated web page that has a text editor. This editor is actually an instance of ACE. Maybe some of you know that one. That's the text editor that is also used by GitHub. So, and here we have integrated our language infrastructure into the ACE editor. So if I do control-space, I get the same list of possible keywords as in IntelliJ. And if I put in my snippet, no, not that one, this one, then you can see exactly the same behavior. So if I do control-space, I get the list of all the defined states for the heating device. And if I change the name here, I get an error marker saying this state is not defined. So we have exactly the same behavior. Okay. What do you say? Do we have some time for the validation? We want to continue?
Maybe in the end.
Okay. Good. I will give back to Sven.
All right. So that was the usual case of using Eclipse to develop IntelliJ plugins. Maybe worth mentioning is that this development of Eclipse, of Xtext projects is also available from within IntelliJ. So the wizard you saw to create an Xtext project, that's also for in JetBrains IDE available. So we could have used that as well. All right, so I have another demo, and this time I'm going to show you something more Java-ish, even more. Let me delete everything. Kill and clean. Okay. So what we just saw is a structural language, like we have devices and rules and so on, right? We can define structures, and that's the easy part. That's like when you think of DSLs, it's often about structures, like you model maybe services or entities or things like that. But then when you generate, for instance, Java code out of that, then at some point you also might want to add behavior. And that has been a problem in this kind of world of code generation, that you always ended up kind of like with this problem that you had this structure being generated from some input information, but then you had to kind of put in some Java code there in order to also have some behavior, because we want to write object-oriented programs and we don't want to have so-called anemic domain models like structure there, behavior there. So the problem here is that it's not especially an easy task to build a proper expression language or statement, so to say, on your own. And there's also not so much value in redefining your own expression language every time, because expressions can be very well abstract through methods. So that's a kind of a solved problem. It can be done in nice ways and not so nice ways, but effectively it's almost always the same. Domain-specific concepts might be literals, maybe for special data types and so on, but the general things like calling methods, having for loops or if or something like that, it's very similar. Because of that, Xtext has a solution that is a language library for this kind of problem that you can reuse, and we call this library Xbase. And I'm going to show you an example that is shipped with the Eclipse distribution. That's why we use Eclipse today here. That is called the domain model example. So we have different examples here you could materialize, also for extend. the language Miro showed you, which is, by the way, fully implemented in Xtext, but also for Xtext. So we have a domain model language, we have a home automation language that's similar to what Miro showed, but it uses Python-like white space indentation blocks and so on. So these are all interesting to look at if you want to learn something. We will look now at the domain model example. This time it's a project that has the runtime compiler and just an Eclipse plugin and a test project. I'll again look at the grammar, but before we do so, I want to look at the actual language by example. So I posted just a comment here down there. So that's the language, or an instance of what I can do with the domain model language. I can declare a package, and then I have nested entities. Very, very simple, very, very straightforward. Not a lot of abstraction, it's just a showcase. Okay, think your own very special things into it. For this, it really just maps to Java classes with getters and setters, a proper string implementation, but not more. But what's noteworthy here is that we can also define operations, including the body. Okay, and if you look at that and you know a thing about language development and you want to have these things being statically typed, then you know that's not a trivial thing. And that's the reason why you don't have to do it yourself, but you can reuse the Xbase library. So here, Miro didn't mention it. In the first line of the grammar, we declare the name of the grammar, but we can also declare what superlanguage we want to inherit from. And by doing so, we inherit all the rules and the grammar rules from this language and can use them in our own language. So we saw the domain model consists of packages here that nest maybe more packages. An abstract element can be a package or an entity, or even like entities. Okay, so this is how it is modeled. Then we have an X-import section here being optional in the start. This is already something we can just inherit from Xbase. The X-import section is a full kind of Java-style import section that also includes auto adding import on content assist, organized imports in the IDEs, and so on. So that's already some kind of a very nice reusable building block. Then we have something called JVM type references. So when we define a property, we say, if you go back to the example, we use a Scala notation, so to say. So we define first the name, then separated with a colon, we have the type. And the type is a Java type. And you see, like, a Java type, if it's a string, then it's simple, but it could be, of course, a generic type, array, whatever, right? Everything that Java supports. And that's covered by the JVM type reference rule. And the most interesting thing is the so-called block expression that is called here as a body of operations. So this is really all the grammar we have. And here we say, at this point, we can have block expressions. And I want to show you in action what that means. So I'll start an Eclipse application. So that is now Eclipse development. If you don't know, it allows you to start a new Eclipse instance that it has installed all the plugins that you have in your current workspace. So I'm actually running the domain model language here, and I played around with it before, so that's why there's already a project, and that's also why there is already a model. I put it in here. Okay, so you see syntax coloring works, of course, but the interesting part here is that we have a full-blown statically typed language, and I have content assist just as you are used to from Java, and I can access all the Java properties, as you see, but it's also like if I go there, I end up here. So it's really like kind of totally integrated. So you see the source.gen folder here, and there is these classes are being generated there. So if I type in here, you see the class here is updated, right? I remove that again. So it's updated as you type, and if you want to see it, you can select anything like the method name, and then you say open generated file, and then you really see the generated Java code. So that's the Java class being generated for the person. But only then. Even if you go like here, that's a plain Java class with the main method, and it instantiates a person. And if you go there, you don't end up in the generated code. It's all seamlessly integrated. You can also kind of debug it, like you run it as a Java application. You end up here, you press step over, and now I press step into, and I end up here. I can say step over, back here. Okay, so it's all kind of like this kind of way of using code generation in Java projects together with the Maven and Gradle integration. That's really what we think is seamless, fast turnaround integration. So you really don't have this extra step of doing code generation and so on so much. All right, that's for the Xbase demo. Okay, I think we're good in time. We should like end with some slides now, or do you want to show the validation stuff? I deleted your project.
Yeah. Sorry, the slides.
All right. That's one way to do it. I'm sorry. Okay, so that's for the demos. Again, all these things work in Eclipse and IntelliJ, and also for the browser stuff. Maybe one thing I want to mention for the browser, maybe that wasn't clear. For the browser solution, it's not a whole IDE thing, as you saw. It's just a text editor, and it's on purpose because we think in this situation you want to focus on like providing these kind of languages to people that are not used to IDEs, and you want to embed these text editors in any kind of web application, and that's also how it's architecturally wise done, so you can really implement it and add it to your web applications. Okay, so some slides on what you also could do with Xtext is, of course, you can combine it with other frameworks to do more visualization, diagramming, forms, whatever. That is because Xtext, when you define the grammar, it's not like only a parser, it's not one direction, it's actually a bidirectional mapping between text and the AST. So from that definition, you not only get a parser, but also an unparser or serializer. That means you can modify the models in memory and write them back to text. And you also keep the white space, you can have this formatting, you keep the comments and so on. So we have a lot of kind of customers and users that use combinations and really use the power of these modeling stuff, but can still like work with the text, work with Git, work with div and so on, have this lightweight text level. It's not going to work. I messed up the slides before, but that's not a problem. I can just do it like that. Actually, the thing is, I tried to put an animation there and I entered 50 seconds. Anyway, so that's another example of forms. Like you have an RCP application and you just have a text field somewhere that is a bit more richer, so you can have this combination also. Or if you think like you can also do a lot of with text, like for instance decision tables like this one. That's a funny exercise for what the formatter can do. So you have this decision table. And once you go into there and change it, it's not so nicely formatted anymore, not so readable. But in Xtext, the formatter API is very powerful, so you can automate it and have, again, a very nice ASCII art style decision table. Yeah, Xtext is around for a couple of years already, as I mentioned in the beginning, so there's also many big users, big companies, known companies, but also many, many more unknown companies and people and from academics that use Xtext. And it's really interesting and exciting to see what people do with it. There's stuff that we couldn't imagine, and that's also the fun of our job, to work with these clients and understand their domains and so on. A friend of ours, Lorenzo Bettini, has written a book on Xtext and Xtend, so if you prefer learning from books, that's a nice one. And that's our last slide, the website, xtext.org. It's on Eclipse.org, and it contains everything you need to get started, kind of like the downloads, documentation, and so on. All right, that's it from us.
Awesome. Well, thanks very much, guys. We've got some questions, and if anyone does have any other questions, they can feel free to put them straight into the IRC. Okay, so you talked about Xtend, and we can see the users. Are there any other languages which use Xtext other than Xtend?
Sorry, Simon. Could you ask again?
Sure. Are there any other languages that use Xtext other than Xtend?
Oh, of course. Yeah. I mean, the company logos I just showed, like they build languages with Xtext. There's a lot of internal languages, but there's also products that you can buy, like for hardware design. There is no other, I think so at least, no other JVM Java alternative that is based on Xtext. Mm-hmm. I don't know why, maybe, but yeah.
And from your experience in creating Xtend, would you say it's fair to say that Xtend is kind of like an interpreter from the Xtend language into Java source?
It's not an interpreter.
Okay.
I mean, there is, for this Xtend, the language is translated to Java source code, so there is a code generator in it. And so it uses the same technique as I just showed with this domain model language.
So that was going to be my question, really. Are there any different challenges or differences between kind of creating Xtend compared to creating a language which would actually result in a bytecode, other than just that final step of creating a different output? Do you have any other challenges for that? Or?
Okay. So I get the question now. No, actually, it's harder to write a language that generates Java code as opposed to generating bytecode, because Java is made for users, and it has a lot of constraints. The compiler has a lot of checks that kind of like is interesting for humans, but when you generate stuff, then it kind of can be cumbersome to deal with these things. And that's not the case for bytecode. It's much simpler in kind of what it allows. Like there's not so many variations and so on.
Okay. Question on IRC from Federico. Have you written any languages which interact with other modules in the same project? So, for example, permit references to Java or Scala classes?
All right. Yeah. I mean, the domain model stuff I just showed that had references to Java. Mm-hmm. So there is for Java, there's for sure deep integration to reference and call Java methods, Java types. I haven't showed it, but it also works for rename refactoring and so on. So it's really seamless integration in the IDE, and it works with the Maven and the Gradle builder. Also, they are incremental for Gradle. So yeah.
Okay.
If you extend as an example, it's no problem to have an arbitrary mixture of Java source files and Xtend source files in your project. And so the interoperation is really seamless.
Okay. In terms of so for a question about specifically about Extend, does Extend currently support Java 8? So push into Java 8 lambdas and streams and things like that.
Yes, so you can choose which version of the generated Java you would like to have. So for the Eclipse integration, for example, the default is to generate the same Java version level as is set up for your project. So as source compatibility level.
Okay.
So and if you choose Java 8, actually and use the extend lambda expressions, then these will actually be translated to Java 8 lambdas.
Okay, cool.
They're much more noisier, but
it's much noisier in Java.
yeah.
Yeah. I played with Extend a while back actually, and it was always quite funny looking at the generated Java. I noticed there's a few like sneaky throws and stuff like that, which always made me chuckle. But it's fun to look at. One final question. I'm just pinging RC now. And the final question from Sunny. Do you have any of this code on GitHub that you've shown today?
Well, the snippets are on GitHub, and what Sven had shown with the other example, that's actually included in Xtext. So if you use Eclipse, there is an example creation wizard for that. That's what Sven had shown in the beginning.
But everything is on GitHub, the whole project. So also everything you saw is on GitHub.
Okay, so if you send us all the links, we can put that in the write-up afterwards. So let me just check if there's one final question. Let's go for one final question from Federico again. How complex is it to run the Xtext generator outside of the IDE, so running in a headless mode?
It's a no-brainer. You can just use a Maven plugin or the Gradle plugin, or you write a couple of lines of Java, like 6 or 7 lines.
Okay, perfect. So with that, I'll say thank you very, very much for a really interesting session. Any questions from Oleg before we?
Oh, I'm good. I was listening, and I will store all my questions for the interview.
Of course.
They are more general about programming languages rather than Xtext.
Okay, cool. So yeah, if you're interested in hearing that interview, that'll be available on Rebel Labs in the next couple of days, as will the write-up. So, yeah, again, thank you very, very much to Sven and Miro, and I'll leave just by mentioning that we have one more session tomorrow. It's actually the final session in the book reading club. So this is the session that is going to be run by Roberto and Ivan. So do join that. This is about design patterns. And then, whoops. There we go. Can you see my screen? There we go. So, and then after that, in the new year, although it says 12th of December, that meant to say 12th of January, we have the cat back on. Venkat Subramaniam is going to be not talking about programming languages made easy, but he's going to be talking. Let me get rid of that. That's just confusing.
That would be nice.
The only thing I got right there was Venkat's name.
To do the session once more.
Yeah, how about that? Well, so Venkat is going to be talking about Java 8 streams, so that's available on the Meetup site now. I'll make sure that this is available to replay. It's currently available on YouTube at the same link. I'll make this available on the Virtual Jug straight away. So yeah, without further ado, thanks very much to Sven and Miro for joining us for the first time on the Virtual Jug. And we'll interview you next. So thanks everyone for watching. Cheers. Bye.
Thank you.
Yeah, thank you. Welcome.